Hi everyone, in this lesson we're going to construct and solve a system of linear equations in the context of a real life problem. And for all the problems, I'm asking you to define the variables, write the system of equations, write the augmented matrix, the solution matrix, and then solve the system for all the variables. So let's look at the first problem. Marina had $24,500 to invest. She divided the money into 3 different accounts. At the end of the year, she had made $1,300 in interest. The annual yield on each of the 3 accounts was 4%, 5.5%, and 6%. If the amount of money in the 4% account was 4 times the amount of money in the 5.5% account, how much had she placed in each account? All right, so there's 3 accounts, so I'm going to use 3 variables. I'm going to let x equal the amount in the 4% account. I'm going to let y equal the amount in the 5.5% account, and I'm going to let z equal the amount in the 6% account. All right, so now I have 3 variables. I'm going to need 3 equations. If I have 2 variables, I need 2 equations. 3 variables, 3 equations. 4 variables, 4 equations. So I have to take the information I can from the problem and set up 3 equations. So the first part of this says that in all the accounts, Marina had $24,500 to invest. So the amount in each of the accounts is going to add up to $24,500. So let's write that equation. And as I take care of each part, I just like to put a check mark by it to just note to myself that I've already used that in my equation. Now the next part says she divided the money into 3 different accounts. At the end of the year, she made $1,300 total in interest. All right, so let's take a look at the next equation. So I had to convert the percents to decimals, and that is the amount of interest that's being applied to the amount already in the accounts. So my second equation is shown, and that addresses the $1,300 in interest. All right, now the last part that I can use in this problem is if the amount of money in the 4% account is 4 times the amount in the 5.5% account, how much had she placed originally in the account? So the amount of money in the 4% account is 4 times the amount of money in the 5% account. Okay, I've done the hard part. I've set up the equations. Now I'm going to put those equations into my augmented matrix. The first equation is in standard form. The coefficients are all 1s. And to the right of this equal sign, it's 24,500. The second equation is also in standard form. So I'm just going to write down all my coefficients. And the value to the right of the equal sign is 1,300. And my last equation is not in standard form, so I would have to take that 4y and move it over. So I'm going to have x minus 4y plus 0z equals 0. And now that that equation is written in standard form, I can transfer that over to my augmented matrix. All right, now we're going to put that into our calculator and write down the solution matrix. We're going to go to second inverse. We're going to go over to edit, hit enter. It's a 3 by 4 matrix. I already have that set up. And then you're going to enter in your augmented matrix. And I've already done that here. Once you've done that, you're going to quit out of the matrix, second mode. And now we're going to apply reduced row echelon form. We're going to do matrix math. So we're going to go back to matrix. We're going to choose math. And we're going to pick reduced row echelon form. Hit enter. We want it to apply reduced row echelon form to matrix A. Hit enter. Now we have our solution matrix. So let's write that in. And since we put our equations in the form of x, y, and z, so we did x, y, and z, our solution is in terms of X, Y, and Z. So the value of X is $8,000. I have $2,000 invested in the 5.5% account, and I have $14,500 invested in the 6% account. All right, so that's it for this problem. Let's move on to number 2. Billy's Restaurant ordered 200 flowers for Mother's Day. They ordered carnations at $1.50 each, roses at $5.75 each, and daisies at $2.60 each. They ordered mostly carnations and 20 fewer roses than daisies. The total order came to $589.50. How many of each type of flower was ordered? All right, so I'm going to define my variables first. I'm going to let C equal carnations, R equal roses, and D equal daisies. Then the next thing we're going to do is identify information from the problem so that we can set up 3 equations. We have 3 variables, we need 3 equations. And the first thing I notice is that the total number of flowers is 200. So if we add carnations plus roses plus daisies, that equals 200. So let's write down that equation. Then the next part of this says that they ordered mostly carnations and 20 fewer roses than daisies. So that's going to be an equation right there. 20 fewer roses than daisies. So R, roses, is equal to daisies minus 20. And then the last equation we can set up is they told us how much each different type of flower costs, and that the total cost came to $589.50. So let's write that equation. All right, now that we have our system of equations set up, we can transfer everything over to the augmented matrix. The first equation is in standard form in the order of CRD. All right, that's the order that I'm going to choose to put each equation in order to make this work. And the coefficients are going to be 1, 1, 1, and then 200 after the equal sign. Now the next equation is not in the order of CRD, so I want to rewrite that. I'll write that in red over here. Right, so we have 0C, because we don't even have C in this equation, plus 1R. I have to move the D over, so I'm subtracting D from both sides, and that just leaves me with a negative 20 on the right. So the coefficients in this case are going to be 0, 1, negative 1, and negative 20. And then our last equation already is in the order of CRD, and then our number is 589.50 on the end, so let's write that in. All right, so we have our augmented matrix set up. Now we're going to go into the calculator, put in the augmented matrix, and do reduce row echelon form. We're going to go to second inverse. We're going to go over to edit, hit enter. It's a 3x4, and we're going to enter in all of our information. I've already done that here, so once you've completed that on your end, we're going to quit. So we're going to go to second mode, and now we're going to do matrix math. So second inverse, go to math. We're going to find reduced row echelon form. I'm going to hit enter. We're going to tell it to perform that matrix math on matrix A. Hit enter. And our solution matrix is there, so let's write that down and then we can interpret that. Right, so remember that we put our equations in the order of C, R, and D. So this is C, R, and D. So we know that we're going to, for each, it says how many of each type of flower was ordered. We know that we have 80 carnations, 50 roses, and 70 daisies. Okay, moving on to number 3. Now at this point in the video, I would try to do 3 and 4 on your own, see how you do, and then come back to the video when you're ready. The Arcadium Arcade in Lynchburg, Tennessee uses 3 different colored tokens for their game machine. For $20, you can purchase any of the following mixtures of tokens: 14 gold, 20 silver, and 24 bronze, or 20 gold, 15 silver, and 19 bronze, or 30 gold, 5 silver, and 13 bronze. What is the monetary value of each token? All right, so first we're going to define our variables. I'm going to let G equal the number of gold tokens, S equal the number of silver tokens, and B equal the number of bronze tokens. And again, we have three variables, so we need three equations. So we need to look at our word problem and see how we can write three equations based on the information given. Right, so we have three different types of situations for the value of $20. So that is going to give us our three equations very easily. We have one equation here, we have one equation here, and we have another equation here. And for all of those scenarios, we have equals 20 on the end. So let's write those out. All right, so we've taken care of this scenario, and this scenario. Now we're going to take our equations and put them into our augmented matrix, and they're all in the order of G, S, and B, gold, silver, and bronze. So we know our result is going to be in the order of gold, silver, and bronze. All right, so let's write in our augmented matrix, and all of these are in that order, so I don't have to rewrite any of them. All right, we're going to put this into our calculator. I'm going to go to second matrix, edit, enter for 3, enter for 4, enter our values. Once we're sure we've entered our matrix correctly, we'll quit out of here. I'm going to repeat my last entry, save myself some steps. So second enter will repeat my last entry, hit enter. I have my resultant matrix, so I'm going to copy that down into my notes and then solve the problem. Remember, the original problem was saying what is the monetary value of each token. So we know that gold tokens are worth 50 cents, silver tokens are worth 35 cents, and bronze tokens are worth 25 cents. Okay, moving on to our last problem. Last Tuesday, Regal Cinemas sold a total of 8,500 movie tickets. Proceeds totaled $64,600. Tickets can be bought in one of three ways. A matinee admission costs $5, student admission costs $6 all day, and regular admissions are $8.50. How many of each type of ticket was sold if twice as many student tickets were sold as matinee tickets? All right, as usual, we're going to define our variables. I'm going to let R equal the number of regular admission tickets, S equal the number of student admission tickets, and M equal the number of matinee admission tickets. All right, we have three variables, so we need to come up with three equations. The first equation, it says we have a total of 8,500 movie tickets. So R plus S plus M equals 8,500. The next piece of information we have is that how much each ticket costs, and that the total proceeds were $64,600. So let's write that equation. I noticed that when I wrote this equation that I put it in the order of regular, student, and matinee, just because that's the way I decided to do it in the first equation. So I did regular, then I did student, and then I did matinee, RSM. All right, so last equation, twice as many student tickets were sold as matinee tickets. All right, this part right here. Twice as many student tickets were sold as matinee. So the student's going to be the bigger number, right? So 2 times matinee gives me student. All right. Now the last equation is not in RSM order, so let's rewrite that so we can get ready to put it in our augmented matrix. We don't have a value for R, so that's 0R plus 1S. I have to move that 2M over, which leaves a 0 on the right side. Now we're all ready to transfer that to our augmented matrix. Okay, we'll enter that into our calculator. Go to second inverse, over to edit, hit enter, enter in our data. Okay, once we have it entered correctly into our matrix, we're going to quit out. We'll repeat the last command, second enter, hit enter. Okay, we're going to write our solution matrix and interpret our solution. And remember, the original question was asking us how many of each type of ticket, and we've done this in the order of R, S, and M, so regular student matinee, so that we know we sold 5,800 regular tickets, 1,800 student tickets, and 900 matinee tickets. Okay, everyone, that's all I have for this video. Thanks for watching. Have a great day.